welcome to the Discovery Center, everybody. Has anybody never been here before? We've all been here before. You've never been here before? You guys have never been here before? Cool. Well, I hope you're having fun, and I hope you see something really cool this afternoon, too. My name is Chris, and I'm going to talk you through one of our science demonstrations that we have. This one has to do with electricity. And now, there's different kinds of electricity. Does anybody know what one of the different kinds of electricity is called? Do you know?
It's the AC and DC, right?
No.
That's current.
Current is the kind of electricity that we're looking for, yes. That. And then there's another type of electricity. Current is the type that moves, and there's another type
Static.
that doesn't move. We call it what?
Static.
Static electricity. Very good. All right. So, you can make your own static electricity. Does anybody know how you can make your own static electricity? I bet you guys have done it. You know how you do it. Okay. If you ever rub your sock feet on the carpet and then shock somebody like that, that's static electricity. Or, if you've ever, like what we're going to do with the balloon here, if you've ever rubbed a balloon on your head, you're creating static electricity. So we're going to blow this balloon up. And is there anybody who'd like to come volunteer to make some static electricity on this balloon for us? You want to do it? Hey, come on. Alright, we're going to have somebody else help us out here in a second too. Come on, right over here. And on the back side, not on the little Discovery Center, guys. On the back side, rub that on your hair. Okay, take it, just rub it on your hair. Just keep doing that for me. Okay, face everybody over here so we can see what happens to your hair when you get it. Keep rubbing. Okay, so what we're doing is we're creating static electricity. Static electricity is made up of negatively charged particles, what we call electrons. Right, they're represented by a minus sign. Okay, minus means negative.
Hey, I can feel electricity on me.
You can feel it already? Good. Hold the balloon just a little bit over your head. Let's see if your hair stands up with it. Okay, hold it up off your head. Just hold it right over your head. Just like that. Okay, can you see that? Keep rubbing, keep rubbing. We lost a little bit there. Okay. Keep going, keep going, keep going. So, the opposite of negative is what? Positive. Very good. And if the negative charged particles are called electrons, what are the positively charged particles called?
Megatron.
Megatrons? Megatrons? Oh, close. But you said it. What was it? Protons. Very good. Yeah. So we have right here lots of electrons, and they're going to make his hair stand up and move around. You can see that just a little bit on it. And on this other balloon, we have actually protons and electrons. It's neutrally. It's balanced.
My hand is hurting.
Your hand's ready. Okay, that's what you're done. Just in time. You're going to hold it right by the top, just like that. Hold it by the top. Now we're going to take his negatively charged part of his balloon and put it close to my part of the balloon that has negatives and positives on it. Let's watch what happens here. You see how they want to kind of pull together just a little bit there? Just a little bit? Just like that? Yeah, they keep pushing close together, right? Now, if somebody else would like to come down here, did you want to come down here and try this? Okay, come down here. And what you're going to do is we're going to go... Thank you. You can go back there. Thanks. Are you coming down? You can come down. Do you want to come? You like purple? Okay, you take the purple. Okay, just come right over here. Now you're going to do the same thing with you. You're going to take that and you're going to rub it on your hair like that. Okay, so keep rubbing it. You're going to stand right here, okay? Stand right here, face everybody, and I'm going to rub this in your neck here. That's like that. So we're going to rub that up. There's lots of electrons on there. Okay? Now what we're going to do, okay, you guys face each other, and you're going to hold this balloon by the very top, just like that. Hold your balloon by the very top. And take your two negatively charged sides and try to put them together. Now what you're going to see happen, and let's twist this around so you have negatives on there. And if you can see what happens on there, well, they're wanting to stick together. Now we must have the opposite sides on there. But hold them close together. What you'll see is this one balloon, you can barely see it on here. It's this one balloon where we put all the negatives on the back side and the negatives on that side, and when they put close together, they want to sort of push away from each other. These aren't doing it so much, but you can tell fairly they're spinning just a little bit like that. So the negatives from her and the negatives from her don't want to stick together. They want to go apart from each other. Okay? So you guys can see this movie. And you can have it. Okay, thank you. You can go back and sit down. So the whole idea is that like signs repel from each other, just like on magnets. If you have two negatives, they're going to push away from each other. If you have a negative and a positive, they do what? They attract. Now, when they're opposites, they attract, right? When they're the same, they push away. So two positives will push away. Two negatives will push away. A negative and a positive will attract. So when we deal with static electricity, we're dealing with negative. So things are going to push away from each other. And that takes us to this machine right here. It's called a Van de Graaff generator. It's called that because the guy who first started building it, his name was Van de Graaff. I don't know what his first name was, I doubt it was Van. But it's somebody Van de Graaff. He built these machines. Now these machines generate static electricity much the same way that rubbing the balloons on our hair does. And I'll show you how this is put together. We have inside here, there's a rubber belt that moves around two pulleys. That creates the friction. That's like sliding your feet on the carpet or rubbing the balloon on your hair. That builds up static electricity. And it stays on the rubber belt until it gets to the top, and it jumps over to this little metal plate that sits right on the back. Okay? Because things that are metal attract electricity very easily. Electricity can pass through them very easily. So the electrons jump over to the little metal plate. The big metal ball sits on top of the whole thing, and all the electrons can go out all over the ball, like that. And it creates a static electricity field. Now it's static, which means it doesn't move. It stays there until it finds something close enough it can jump to, or until it just dissipates. So when we turn it on, this is what you hear. The first thing you hear is the belt moving. And then after a second, if we're lucky, we'll hear the crackling. You guys hear that? Really? That's the static electricity building up inside there. Okay?
Where are the Van de Graaff?
Do what?
Where are the Van de Graaff?
The Van de Graaffs are not here. Okay? It's not generating Van de Graaffs, it's generating electrons. Okay. So now, if you see that line down at the bottom, it says danger high voltage 400,000 volts DC. Now what that means is that its strongest power, it can shoot 400,000 volts of direct current into whatever touches it or gets close to it. Now we don't ever let it run long enough to build up that much power, but we do let it run long enough to get some nice little sparks going. So, to see the electricity, we have to turn the lights out here. So Cynthia, you'll get the lights for us. What we're going to do is we're going to take this little one, which is a metal ball on top of this little stick, and we're going to hold it close there so the electricity can jump from the machine over to here. Let's watch. You guys see that? Yeah, let me show you guys on the other side right here. See that spark? Now what does that spark look like?
Electricity.
Like lightning, right, yeah. And in essence, that's what it is lightning. Lightning is just a giant bolt of static electricity. Much stronger than what the Van de Graaff machine can create. Like that. Okay. And so that's what it does. It builds up that static electricity until it has somewhere to jump to, the ball when it gets close enough, and the electricity jumps over to the ball, and then we get that nice little spark. Okay, you can turn the lights back on for it. Now when we turn the machine off, it's important to remember this. It's static electricity, it stays. So there's still some electricity in the spark. It's close enough.